Walking the Earth around 1.5 to 1.9 million years ago, Homo erectus is perhaps the most fascinating of our ancestors. Emerging from the humble tree climbing and occasionally upright standing Homo habilis, these ancient humans were the first to truly resemble modern humans, sparking a sense of kinship across the ages. But it wasn't just their appearance that set them apart. They also laid the foundations of our civilization by harnessing the elements and understanding their own biology. From feats like controlling fire to the early development of language, these prehistoric pioneers are the silent architects of our existence. But who were they? What did they look like? How did they think? And perhaps most importantly, how did these ancient humans shape the very foundations of the society that we continue to build today? To uncover the answers, we must journey back in time to an era when the spark of humanity first ignited and humans first learned how to harness the earth in their minds. In 1891, Dutch anatomist and paleontologist Eugene Dubois set out on an expedition to the Dutch East Indies, present-day Indonesia, hoping to find the missing link in human evolution. The missing link theory emerged in the 19th century during the early days of the evolutionary theory. It referred to a hypothetical extinct creature that bridged the evolutionary gap between modern humans and their primate ancestors, particularly the modern chimpanzees. The big idea was to find fossil evidence demonstrating the transition from apes to humans, and everyone was eager to find it. But what Eugene would come to find would be more than he ever expected. Driven by the conviction that the origins of humanity could be traced back to the tropics, an idea inspired by the distribution of modern primates and early human fossils, Eugene set out for adventure and chose the island of Java as his primary focus. With its geological layers and ancient deposits, Java at the time seemed like not just a promising location, but the best possible site for discovery. Luckily, after years of painstaking exploration and excavation, his efforts paid off. In a region called Trinil, along the banks of the Solo River, in October 1891, Dubois' team unearthed a fossilized skull cap, popularly known as Trinil II, that had distinct features unlike those of modern humans or known apes. They had found a piece of the proverbial missing link. This skull cap had a prominent brow ridge, a low-sloping forehead, and a brain size intermediate between that of apes and modern humans. After extensive study, in 1892 they found a thigh bone nearby that further supported the idea that this was a bipedal species. Dubois named his find Pithecanthropus erectus, which means upright ape man. However, this discovery was later reclassified as Homo erectus, fitting into the broader human evolutionary tree. Although human evolution is now understood as a branching process rather than a linear one, Eugene Dubois' discovery opened the door to findings that would change everything we knew about ourselves. Many years after Eugene Dubois unearthed Java man at Trinil in the 1920s and 1930s, a series of finds known as Peking man were made at Zhoukoudian near Beijing, China. These fossils included several skulls and bones, and provided substantial insight into the Homo erectus species. In 1984, Kamoya Kameo changed the game as he discovered the nearly complete skeleton of a young male, known as Turkana Boy, near Lake Turkana, Kenya. This find offered valuable information about the physical structure and growth patterns of Homo erectus, and still continues to do so today. Additionally, the fossils found in the 1990s in Georgia included several skulls and jawbones, showcasing significant variation and expanding our understanding of early human migration. Although, at the time, not much was known about the species, one thing was clear: they were definitely something special. Homo erectus first appeared on Earth approximately 2 million years ago during the Pleistocene epoch. New species of ancient humans marked a significant evolutionary step that still baffles scientists today. Unlike their predecessors, the Homo habilis, who still spent time in trees, the new Homo erectus had a fully upright posture and was adapted to living primarily on land. Contrary to what you might believe, Homo habilis was not extinct during the emergence of Homo erectus, and they would have hypothetically interacted with their ancestors as they both tried to navigate the changing world together. Dying out just around 108,000 to 117,000 years ago, Homo erectus set the precedent for multiple human achievements, and perhaps the most important is that they were the first species to wander out of Africa, conquering new lands and spreading across the globe. These ancient explorers initiated a new way for mankind, one that would directly lead to more subspecies in the human family tree, specifically Homo heidelbergensis and Homo antecessor. Due to their wandering, Homo erectus is believed to be a direct ancestor of Homo heidelbergensis, which lived in Europe and Africa around 700,000 to 200,000 years ago. Homo heidelbergensis, in turn, is considered to be an ancestor of both the Neanderthals, also known as Homo neanderthalensis, popularly called cavemen, and modern humans of today. Besides Homo heidelbergensis, another descendant of Homo erectus is Homo antecessor, primarily found in the Iberian Peninsula. This species, however, is different from Homo heidelbergensis, as it exhibits a mix of archaic and modern traits, indicating a transitional form between Homo erectus and later Homo species. But what led to the evolution of Homo erectus? Well, to understand this, we need to look at the isolation theory. The theory suggests that geographic and environmental barriers played a crucial role in the speciation and evolution of Homo erectus. According to this theory, a population of Homo habilis became isolated due to physical barriers such as mountains, rivers, or deserts. Over time, natural selection acted on this isolated population, leading to adaptations that eventually caused significant differences from their ancestors. This theory is supported by fossil records indicating that Homo habilis and Homo erectus coexisted for a period, suggesting a gradual evolutionary process. Thus, the lack of geographic isolation in regions like Africa and Asia facilitated the emergence of distinct traits in Homo erectus populations, contributing to their eventual divergence from Homo habilis. Unfortunately, after dominating the world for more than 1.5 million years, Homo erectus populations gradually declined and eventually disappeared. The last known population lived on the Indonesian island of Java, known as Homo erectus soloensis. Remarkably, this group persisted until about 108,000 years ago. When considering the demise of Homo erectus, several factors can be identified as the main causes. One significant factor was climate change. The transformation of open woodlands into tropical rainforests in some regions created environments less suitable for Homo erectus, ultimately leading to their decline. But that was not all. The emergence of more advanced Homo species, such as Homo sapiens and Neanderthals, increased competition for resources, further contributing to the decline of Homo erectus. Sadly, or despite their adaptability, Homo erectus faced limitations in surviving drastic environmental changes and competing with more advanced hominins. Those that did not evolve into new species or adapt quickly enough eventually perished. But what exactly allowed them to last so long? How did they survive in the world? And not only survive, but become an apex predator. When it comes to appearance and somewhat human-like anatomy, Homo erectus was the first ancient human to look anything like modern humans today. So much so that you could dress one up and have them walk down the street undetected, of course, after a little makeup here and there. Help the ancient wanderer look more like us and less like a member of the uncanny valley. Homo erectus was quite a marvel to the scientific community, as it exhibited a range of anatomical and behavioral traits that marked significant evolutionary advancements. Advancements that still influence us today. Standing fully upright and completely adapted to walking and living on Earth, Homo erectus's bipedal posture provided the necessary capabilities for their migratory lifestyle, allowing them to walk long distances and explore new lands, typically standing between 4 and 6 feet tall. Homo erectus individuals had a robust and muscular build, with thick bones and strong muscle attachments, indicating a life filled with physical activity. In fact, Homo erectus had a wide range of body sizes similar to modern humans. They varied in height from about 4'9" to 6'1" and weighed between 88 and 150 pounds. These differences were likely due to variations in climate, mortality rates, or nutrition across different regions. However, unlike other great apes, there doesn't seem to have been a significant size difference between Homo erectus males and females, although there isn't much fossil evidence to confirm this. This potential lack of sexual dimorphism was surprising, as if Homo erectus didn't show sexual dimorphism, they might have been the first in the human lineage to lack this trait. Homo erectus had limb configurations and proportions similar to those of modern humans, suggesting they were capable of human-like walking and running. This theory is supported by footprints found near Illoret, Kenya, which show a human-like gait. They also had shoulder structures that could allow for high-speed throwing. Initially, it was thought that the Taboy fossil had a different number of vertebrae compared to modern humans, but later findings confirmed that it had a human-like spinal curvature and the same number of vertebrae. Moving on from skeletal structure, the timeline for when human ancestors lost most of their body hair remains unclear. Genetic analysis suggests that dark skin, which protects against UV radiation, evolved around 1.2 million years ago, possibly indicating the development of hair around that time. This change might have been necessary for survival in environments with high solar radiation. It is believed that early Homo species living in lower, hotter regions might not have needed body hair for warmth as much as their Australopithecine ancestors, who lived at higher, colder elevations. As a result, Homo erectus populations in higher latitudes might have developed lighter skin to prevent vitamin D deficiency. In fact, one specimen from Turkey, dating back 510,000 to 300,000 years, had the earliest known case of tuberculosis meningitis, a condition worsened by vitamin D deficiency in dark-skinned individuals living in higher latitudes. Hairlessness in Homo erectus is generally thought to have helped with sweating, reducing parasites, and possibly sexual selection. Facially, Homo erectus featured prominent brow ridges and a sloping forehead, giving them a distinctive profile, a profile that would be modified over the years by evolution to produce the human face we recognize today. In the mouth region, Homo erectus had jaws that projected outward more than those of modern humans, accommodating larger teeth suited for a diet of tough, fibrous plant material and meat. Their dental enamel was the thinnest of any Pleistocene hominin. While this thin enamel prevented their teeth from breaking when eating hard foods, it made it more difficult to shear through tough foods, so their diet had to be adapted accordingly. The jaws of Homo erectus, like those of all early Homo species, were thicker than those of modern humans and living apes. This thickness helped them resist twisting forces from biting or chewing, allowing their jaws to withstand powerful stresses during eating. However, the mandibles of Homo erectus were somewhat thinner than those of earlier species. Homo species premolars and molars showed more pitting than those of Homo habilis, indicating a diet that included more brittle foods. These dental traits suggest that Homo erectus's mouth was less suited for processing hard foods and was better adapted for shearing tougher foods, likely due to the use of tools. But perhaps their most notable anatomical development was their projecting nose, an adaptation that helped humidify and warm inhaled air, and, as a result, ensured they could survive in varied and often dry climates. An alternative hypothesis proposed by American psychologist Lucia Jacobs suggests that this projecting nose allowed Homo erectus to distinguish the direction of different smells, helping them better navigate the ancient world and travel long distances. In terms of brain size, Homo erectus had a capacity ranging from approximately 600 to 1,100 cubic centimeters, averaging around 900 cubic centimeters. This was a substantial increase from their predecessors, although it remains smaller than the average modern human brain, which is about 100 or 350 cc. The cognitive abilities of Homo erectus also evolved over time. Early populations had brains that ceased developing at a younger age, limiting their capacity for learning and adaptation. However, later Homo erectus populations showed signs of continued brain development into later stages of youth, similar to modern humans, allowing for enhanced learning and adaptability. This enhanced learning and adaptability led to some remarkable discoveries by the species, but we will discuss that soon. Recent studies have shown that the brain size of Asian Homo erectus over the last 600,000 years is quite similar to that of modern humans. In fact, when comparing brain sizes, some present-day human populations actually have brain sizes that overlap more with Homo erectus than with modern humans, who tend to have larger brains. Essentially, this research highlights issues with our current understanding of how brain size has evolved, as it does not account for differences between populations. The average brain size of Homo sapiens has increased mainly because the largest brains have grown bigger, while the smallest brains haven't changed much compared to Homo erectus. This increase is more noticeable in northern populations, likely due to body size and climate factors. Because of these brain size similarities, Some researchers suggest that Asian Homo erectus could be classified as a subspecies of Homo sapiens, called Homo sapiens sapiens, as earlier researchers initially proposed. Another fascinating fact about Homo erectus is that they most likely possessed a proto-language, meaning they had more complex communication than any earlier hominids. However, they did not have fully developed speech. Scientists believe this emerging communication ability is mainly evidenced by the discovery of a hyoid bone, which is a small U-shaped or horseshoe-shaped bone located in the midline of the neck, anteriorly at the base of the mandible, and posteriorly at the fourth cervical vertebra. This bone supports the tongue, plays a key role in speech and swallowing, and suggests that some vocal communication was possible. When comparing Homo erectus to modern humans, several differences stand out. For example, modern humans have flatter faces, less pronounced brow ridges, and larger brain sizes. Our bodies are lighter, with thinner bones and less pronounced muscle attachments, reflecting a less physically demanding lifestyle. However, these differences are simply a polished and better evolved version of those found in Homo erectus. Essentially, Homo erectus represents a crucial step in human evolution, with significant advancements in anatomy and behavior. But why did they evolve as they did? What was their environment like? And how did their diet influence this evolution? Let's find out. First, appearing on the open plains and savannas of Africa around 2 million years ago, Homo erectus was one of the most successful and widespread early human species, demonstrating remarkable adaptability to diverse environments and dietary sources. This successful and widespread early human species exhibited remarkable adaptability to diverse environments and dietary sources. Their existence spanned several million years, during which the dynamic climatic shifts of the Pleistocene epoch profoundly influenced their lifestyle, migration patterns, and survival strategies. For example, glacial and interglacial periods caused significant changes in global climates, leading to shifts in habitats and resource availability. These changes forced Homo erectus to migrate, adapt, and innovate continuously, including returning to Africa, where it all began. Homo erectus emerged from environments rich in large herbivores and dangerous carnivores. These environments presented both significant opportunities and challenges because the vast grasslands teem with game, providing ample hunting opportunities, while the woodlands and forested areas offered shelter and a diverse array of plant foods, creating a mixed habitat that supported a very varied diet. As Homo erectus migrated out of Africa, they encountered the mixed forests and open plains of Europe. These regions required different strategies, as Northern Europe, with its colder climates and mountainous regions, demanded adaptations to withstand harsher conditions, leading to a completely different set of evolutionary traits and even the development of constructed shelters. More on that later. As they moved into Asia, Homo erectus adapted to an even broader range of environments, as the tropical rainforests and open woodlands in Southeast Asia provided lush but challenging habitats teeming with new flora, while plains and wetlands in India and China presented different ecological niches, requiring Homo erectus to be versatile in their tool use and dietary habits. Essentially driven by the need to find suitable habitats and resources, Homo erectus migrated across vast distances, adapting to diverse environments along the way. This extensive migration led to the development of distinct regional subspecies, such as Peking man in China and Java man in Southeast Asia. So, what did they eat? Homo erectus is often considered one of the first human species to truly embody the role of apex predators. This is because they were proficient hunters and hunted large mammals like antelopes, swine, rhinoceroses, hippopotamuses, and even elephants. They were able to do this thanks to their advanced stone tools, which included axes, knives, pickaxes, and cleavers, essential for hunting and butchering large game. In addition to meat, Homo erectus had a diverse plant-based diet. In fact, archaeological evidence from Israel indicates they consumed over 50 different types of fruits, vegetables, nuts, and seeds. This diet suggests a sophisticated understanding of their environment and the nutritional value of various food sources. Essentially, for survival, their ability to gather and process plant foods was crucial, especially in regions where large game was scarce. While the development of sophisticated tools allowed Homo erectus to exploit a wide range of food sources, The true game changer was the invention and use of fire. Being the first human to harness fire, it provided warmth and protection and enabled the cooking of food, which improved its taste, nutritional value, and safety. Cooking made certain plant foods edible and more digestible, allowing Homo erectus to expand their dietary repertoire. Continuing the revolution in human evolution, it is believed that Homo erectus had a more advanced and structured lifestyle compared to their predecessors. They are most closely associated with the Acheulean stone tool industry, a stone tool industry of the lower Paleolithic period that included hand axes, cleavers, picks, and early forms of stone knives. This stone tool industry was known for making tools chipped on both sides to create sharp edges. The most common tool was an almond-shaped hand axe made of flint, about 8 to 10 inches long, with the entire surface flaked to create cutting edges. These tools were essential for cutting, scraping, and processing meat in later populations. Particularly in Java, Homo erectus even used bows made from string and stones to capture prey. But the stone tools were not their most impressive feat. As Homo erectus was the first to harness and control fire, they used fire for warmth, light, protection from predators, and cooking food, which made it easier to digest and safer to eat. Evidence from sites in Kenya suggests they transported fire from natural sources to their settlements, using materials that burn slowly. Learning to create sparks by striking rocks together was essentially the ability to use fire, which was a revolutionary step with significant implications for their daily lives and ours today. But once again, they didn't stop there. As Homo erectus also experimented with construction, some Homo erectus built basic dwellings using simple structures made from branches, rocks, and mud. These shelters found in Europe and Africa provided protection from harsh weather and may have been used seasonally, particularly in colder regions. The construction of these dwellings indicates an understanding of the need for shelter and a capacity for planning and cooperation skills we still use today, albeit in more advanced forms. Moving on from shelter, although the origins of clothing are uncertain, scientists have dated them to have existed at least 3 million years ago during the Homo erectus era. Evidence of head and body divergence around 170,000 years ago suggests that clothing was used even before modern humans left Africa. It is believed that animal hides were likely among the earliest materials used for clothing. And that's not all. Homo erectus possibly engaged in seafaring as early as 1 million years ago, as evidenced by artifacts found in Indonesia. Additionally, Homo luzonensis, which lived on Luzon Island in the Philippines between 771,000 and 631,000 years ago, indicates early maritime capabilities. Evidence also suggests that Homo erectus practiced rudimentary healthcare. For example, a specimen of Homo erectus known as gorgeous had lost most of their teeth due to age or gum disease, but survived for several years, possibly with assistance from other group members. The individual even had spinal disc degeneration, which likely caused lower back pain and restricted movement, yet he still survived into adolescence. Regarding art and rituals, there are indications that Homo erectus may have engaged in symbolic behavior. Engraved shells and beads, as well as the possible intentional collection of red pigments like ochre, suggest a level of creativity and aesthetic sensibility. However, interpretations of some artifacts, such as the Venus of Tantan, are debated, with some suggesting they represent early attempts at depicting human forms. When we think of the past, we rarely focus on similarities, but rather on how different we are today. Thanks to Homo erectus, we can now look back at the past and see a continuous chain of evolution, as countless humans, ancient and modern, have evolved to shape who and what we are. But what do you think, are Homo erectus truly the founders of today's human lifestyle? Or is there still much to discover in the story of human evolution? Let us know in the comment section below. And while you're at it, make sure to leave a like and subscribe to the channel for more prehistoric knowledge. Until next time, stay curious.